In this video, we're going to talk about power series, and we're also going to talk about interval and radius of convergence. If we go back to our Taylor and Maclaurin polynomials, when I introduced it with cosine of x. So I first started with the cosine curve. I added in a polynomial graph, and I think I did it as 4 terms, and it did something like this. And then I added another term, we graphed it, looked like that, and then I think I added one more term to get something like that, and then it separated, let's say there. So we came up with a few conclusions. First one was that around the center, all my polynomials matched my cosine curve perfectly. The further away from the center we got, it started to separate. And we also said, well, what if we were to add more terms to it? It would be more accurate longer. And then we talked about e to the x. We said that, let's say, for example, x is 2. If I said e to the 2, we know that we can approximate it by using a polynomial, like that. If we want it to become more accurate, we would just add another term to it. So it's still an approximation, though. So 1 plus 3 plus 3 squared over 2, and so forth and so on. We even talked about, what if we went all the way to infinity? And we did say if we went all the way to infinity, so e to the, let's say 4. Let's say I wanted to plug in 4, and I wanted to say that it is equal to, I could do 1 plus 4 plus 4 squared over 2 plus dot, 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 dot. That implies it's a series. I go all the way to infinity. This value here will exactly match that value there. And we did talk about that. And we also said that it doesn't work for all x values. For e to the x, it does, but it doesn't all the time. And that's what we're going to do in this video. We're going to come up with, for what x values does it actually work. So the first takeaway is, we said at the center, it will always converge. So that's the bare minimum. It's always going to converge at the center. More often than not, we're going to get it to converge between 2 values. So let's say, for example, we come up with, let's say, -1 to 1. It converges for just those x values. For something like this, the center would be 0. It's right in the middle. The radius, so this would be a center of 0. Radius of 1, because 0 is in the middle, I go out 1 to either side, and this would be called the interval of convergence, -1 to 1. We could have an interval of convergence where maybe it works for one endpoint, but doesn't work for the other. Again, this would be my interval of convergence. My center would be 0. My radius would be 1. This is what we're going to spend most of our time on. Okay, worst case scenario would be it only converges at that one point at the center. That's very unlikely. This more likely, and sometimes it does converge for all x values. E to the x is an example of that. You could plug in any x value, and you will get the value of the function to equal the sum of the series for all x values. So when that's the case, we could say it's -infinity to infinity. That would be my interval of convergence. But my radius would also be infinite. In this case, the center is 0. So e to the x is a good example of that. So what is a power series? A power series is going to be a series that generates a polynomial with x's in it. Because I want to be able to plug in some x value. Yes, please try to understand what we're doing. We're trying to find the value of a function. And I keep saying we're using e to the x, but let's say e to the some number. So let's say e to the 5th by using this Taylor series. That's what we're doing. So my polynomial has to have x values in it. That is a power series. So if you look here, we've got, if I plug in my n to the 0 power, we get no x. If I plug in 1, I get x to the 1st power. We have x to the 1st power. I plug in 2, x squared, plug in 3, x cubed, and so forth and so on. Okay? This would be a power series centered at 0. This would be a power series centered at c. So you can tell a lot of times from your series when you look at it. Notice here it's not x minus something. Here it's x minus c. That's my center. My center is 0. So these are the three scenarios I talked about off to the right, up here. We're going to have either radius of 0 means it only converges at the center. Most likely what's going to happen, it will converge between two values, and then sometimes it will converge for all values. So we're going to use the ratio test to do this. So I went ahead and I got the ratio test set up. Remember, for ratio test, you're plugging in n plus 1 for all of your n's. So when we simplify this, this becomes x to the nth times x, cancel, cancel. This becomes n plus 1 times n factorial, cancel, cancel. So I'm going to take the x out, and we've got the limit as n goes to infinity of n plus 1. So when I plug this in, it's infinite. So when this happens, it only converges at the center. So only converges at center. In this case, the center is 0. And the way you could think of it, if x was 0, for the ratio test to converge, we know it has to be less than 1. This has to be 0 so that when I multiply it by any number, I get 0, which is in fact less than 1. Okay, so if you get infinite, it's going to converge only at the center. So the next one, I went ahead, just for time purposes, I went ahead and I applied the ratio test, plugged in my values. Let's see what happens here. We need to start canceling. So we're going to get x to the 2n. This becomes x to the 2n, x to the third. But then it becomes x squared. So I end up with x squared. This becomes 2n plus 3, 2n plus 2, 2n plus 1 factorial. So this cancels with this factorial. We get 2n plus 3 and then 2n plus 2. So I'm going to take out my x squared. So we're left with 1 over 2n plus 3, 2n plus 2. We know that this goes to 0, which means that, as I know it's backwards of what we think here, but you have to, don't think of these as indeterminate forms. Just think of this as, if this is 0, then this can be any number. Don't think of it as infinity, just think of it as any number I plug in. I can plug in a random number and I times it by 0, I'm going to get 0, which is less than 1, which makes it converge. So that means that my radius is infinite here. That means x can be anything. Okay, so r equals infinity. My center here was 0. And then my interval of convergence will be negative infinity to infinity. Some of you might just need to memorize it if you don't understand it, but don't think of this as infinity times 0. Think of it as this will always be 0, so this can be any number. If I plug in 10, 10 times 0 is 0. If it's 100, 100 squared times 0 is 0. Okay, so again, that works for all values of x. All right, again, I went ahead and I did the ratio test here. Let's see what happens when we cancel. So this cancels. Remember, you're plugging in n plus 1 for all of the n's. Cancel, cancel. I'm going to take out the x portion of it. So we get x minus 2 over 2. And I've got the limit as n goes to infinity. And we're left with n over n plus 1. So that goes to 1. So we have n over n plus 1. So this goes to 1. So I'm left with this. Now, since this is the ratio, we're using the ratio test. We want x minus 2 over 2 to be less than 1, greater than negative 1. By forcing that, that will tell us what x has to be. So we're going to get negative 2 less than x minus 2 less than 2. X is less than 4, greater than 0. Okay, so that's sort of my interval of convergence. We do need to test the endpoints. So we're going to test the endpoints. Let's talk about a couple of things. The center is in the middle of that, so the center is at 2. So the center at 2. If you look at the original function, we knew that because it's x minus 2, the x minus c. Okay, and then the radius we know for sure. So the radius of convergence is 2. So make sure you read the question. Sometimes on the AP exam, they ask you for the radius of convergence. Sometimes they ask you for the interval of convergence. So you're going to test the endpoints. What does that mean? You're going to go back to the original function. So let me do it over here. You're going to plug in 0 and 4 for all of the x's. So if we start with let x equal 0, so I'm going to rewrite it. So we have n equals 0 to infinity. So it's negative 1 to the n plus 1. So I'm plugging it in for this x. So x is 0. 0 minus 2 gives me negative 2 to the nth power over n times 2 to the nth power. So we've got a lot of negatives going on here. So let's see if we can clean this up a little bit. So I have negative 1 to the n. So I have negative 1 to the n times negative 1. For negative 2 to the n, we can break it up as negative 1 to the n times 2 to the nth power, and then n over 2 to the nth power. So this ends up going away because you're going to get negative 1 to the 2n, which is even. So that's gone. So we have 2n. This cancels. So we have negative 1 over n. That is not an alternating series. That is just a negative 1. You can take out the negative 1. So we could do negative 1, n equals 0 to infinity, 1 over n. This is p series, so p equals 1, so this diverges. So that tells me that what did I put 0? So it's going to be 0. And now we have to do the 4. So we're going to do the same thing. Now we're going to plug in the 4. So we're going to get so x is 4. So 4 minus 2 is 2, 2 to the nth power. And then n times 2 to the nth power. This is AST. This is definitely alternating series. So this is the alternating harmonic. This one converges. That's enough for that, okay? They just want you to test the endpoints. Once we start doing Taylor series, the FRQs, you're going to see they're very complicated. You want to get a ratio test, 100%. So easy to do. It's very mechanical. You plug in the n plus 1. You're going to get something where you have to test the endpoints. It's usually an easy test, geometric p-series, AST, and then we can come up with our interval of convergence. So it converges for the 4, so it's 0 to 4. All right, for number 4, I'm going to go ahead and skip the ratio test for time here. So when you do all of this, you should end up with, so this is number 4. You take out the x minus 3 over 4. I've got the limit as n goes to infinity. And we get m plus, I can't read my handwriting, but I think it's m plus 1 over m plus 3. So all of this goes to 1. So I have x minus 3 over 4 less than 1, greater than negative 1. So I get x minus 3 is less than 4. And then greater than negative 4. So we get x is less than 7, negative 1. So the center here is 3. The radius of convergence we can say is 4. But the interval of convergence, we're going to need to test the endpoints. So we're going to test the endpoints. So test endpoints. We start with x equals -1. I'm plugging it into here. So -1 minus 3 is -4. So we have n equals 0 to infinity. So we're going to get -4 to the n plus 1 over n plus 1, and then 4 to the n plus 1. So this, again, we could break this up, I suppose. So n equals 0. So you get -4 to the nth, -4 to the first, 4 to the nth, 4 to the first, and then n plus 1. So this is alternating series because even though these cancel, we still get -1 to the nth power. This cancels with this. We can definitely take the negative out, but it's still not going to change the fact that it's alternating series. This is what makes it alternating. So this is AST. So this converges by AST. I wouldn't spend too much time. I don't think you have to show AST, that the limit as n goes to infinity. You're only going to get 1 point on the AP exam for this. And you're just asked to test the endpoints. So AST converges. So that was for the -1. And then when you plug in the 7, we end up with so we get 4 to the n plus 1, n plus 1, 4 to the n plus 1, cancel, cancel. So this one's tough because it is kind of a lot of work for just this, but so this one it's not AST. It's not P series because you have the n plus 1. This is a comparison test. So either you're going to have to do direct or limit comparison. I did limit comparison to 1 over n, and it diverged. So this would be -1 to 7. Okay, for this one, I went ahead and I did the ratio test. Plugged in n plus 1. Cancel, 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 cancel. I like to take. So we get x plus 2. I'm at the limit as n goes to infinity. So it's 1 over n plus 1. This goes to 0, which means this can be anything. So my interval of convergence would be -infinity to infinity. My radius of convergence would also be infinity. For number 6, what I did, because of the way it was set up, was I just did the root test. Remember, for the root test, you could just take the nth root. So we're going to get the limit as n goes to infinity. So we end up with x minus 3 over 2. So I get x minus 3 limit as n goes to 2 of 1 over 2. So when we plug in here, we get a half. So this equals 1/2, this part of it. So we're going to get x minus 3 over 2 less than 1, greater than -1. So x minus 3 is less than 2, greater than -2. So we get x is less than 5, greater than 1. And then we just want to check the endpoints here. If we let x equal 1, you end up with -2 to the nth over 2 to the nth. This just ends up giving us -1 to the nth, 2 to the nth, 2 to the nth, like that. So get -1 to the nth power, that diverges. And then for the other one, we're going to get the same thing, but it's really just 2 to the nth over 2 to the nth, which is 1. This diverges. So we leave it. So 1 to 5 would be our interval of convergence. My radius of convergence here would be 2. All right, last one, I went ahead, did the ratio test. So we got cancel, 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 cancel. So we get 1/2 on the inside. I have x plus 1 on the outside. I've got the limit. As it goes to infinity of 1/2. So this goes to 1/2. So we have x plus 1 over 2 less than 1 greater than negative 1. So we get x plus 1 is less than 2 greater than negative 2. So we get 1 and negative 3. If we plug in x equals negative 3, you're going to get negative 1 to the nth. We get negative 2 to the nth over 2 to the nth. So again, that equals 1, which is just going to diverge. And then if I let x equal 1, we've got n equals 0 to infinity. I forgot that up here. You get negative 1 to the nth, 2 to the nth, 2 to the nth, and again, this just diverges. So my interval would be negative 3 to 1. My radius here is 2. So radius of convergence is 2, and then interval of convergence is right there.